Now, as you may already know, there are two types of NURBS object you can create inside of Maya. You can create curves and you can create surfaces. Now, it's vitally important that you keep in mind that these two types of objects, are essentially two sides of the same coin, if you think about it. Now, here's what I'm talking about. Let me go ahead and create a curve. We'll grab the CV curve tool, and we'll just in the side view, make it a nice wavy curve, and we'll come back up here to perspective. I'm going to duplicate it. I'll select both curves together. We'll go to surfaces and run a loft. Booyah! And with that, let's go ahead and grab our two curves. We'll nuke those out. We now have a beautiful NURB surface. In fact, hang on, let me hit undo. I'm going to let's leave one of these curves in place. Let me delete history off this guy, so edit, delete by type, history, and I'll delete out one curve. We'll leave the other one here, just so that everybody can see. We have a NURBS curve and a NURB surface. Now let me start off by talking about curves. What is a NURBS curve? Well, you know the whole thing with NURB standing for non-uniform rational B-spline, and that name basically means that it is a series of segmented curves that are defined with mathematical equations and all of this technical stuff. As a modeler, you do not need to bog yourself down with all of that. Honestly, just as a modeler, I have never really sat back and worked with the math on a NURBS curve. Never really needed to, and I've made some wonderful NURBS models. Let me hit 3 on my keyboard to make the curve nice and smooth. Essentially, you can think of a NURBS curve as a one-dimensional object. Now, what does he mean when he says one-dimensional? I mean, it's clearly here in 3D space. In fact, if I were to rotate it a little bit, it is now moving in all 3 axes. I mean, it's got some x-axis motion, some z-axis motion, and some y-axis motion. What does he mean when he says one-dimensional? Well, NURBS has its own coordinate system that exists only on the surface, called U and V, and we'll be talking about that a little bit more as we progress through this video. For now, think about the NURBS curve not in the space that it's maintained in, not in 3D space. Think about it as its own coordinate system. It only moves in one direction. In this case, it's the U direction. If I were to right mouse and select Control Vertices, notice that I have a little square CV up here, Control Vertex, and right here I have a CV that looks like a U. That stands for the U direction, which is the only direction that curves can travel. And a curve, so this is where some people start to get confused, a curve can go anywhere at once in 3D space, in 2D space, in its own space, its own coordinate system. It is only moving in the U direction. NURBS curves also have a beginning and they have an end. If I go back and take a look at Control Vertices again, you'll notice that the CV on one end looks different than the CV on the opposite end. That is because the little square CV, that's where the curve started, and here's where the curve actually ends. This is going to be important for when you try to attach curves together. The end of a curve can only attach to the beginning of a new curve, unless you switch some things around, which I'll talk about. There's always an exception to every rule in Maya, isn't there? Let's go ahead and we'll create a curve here. Now notice, I started here, I ended here. And then let's create another curve, dun, 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 dun. Like so. We'll grab the two curves, and let's just go to Edit Curves and tell Maya to attach. And it looks like everything attaches fine. But if you look in your Attach Curve node, you have Reverse 1 and Reverse 2. Notice how Reverse 2 was automatically set to On. Maya realized that these two curves were touching end to end. So the end of one curve and the end of another curve were near one another. That means they couldn't properly attach. What should have happened was this. The end of this curve should have wrapped around to the beginning of this curve. But Maya's a little bit smarter than that, and so it has swapped the direction of the second curve to make the attachment like Maya thought we wanted to. This is one of the things that Maya is going to do a lot as you work with NURB surfaces. It is going to try to take a guess to give you what it is you seem to be looking for. In this case, Maya knew that we wanted this end to attach to this end of the curve, like so, so we ended up with an attachment point right here. To do that, Maya had to reverse the direction of this second curve. The only problem is that sometimes Maya will guess wrong, and you're going to discover that as you work more and more with NURB surfaces. If you're ever trying to avoid a situation where Maya will have to do any guesswork whatsoever, you can specify a specific point along a NURBS curve to do an attachment. So we grab a curve point here, And we can grab a curve point here. So I've held down Shift. I've got 2 curve points. And now if I go to Edit Curves, Attach Curves, boom, they attach like that right there. And that is because I explicitly told Maya where I wanted them to attach. If I want to, I can grab 1 curve point here and 1 curve point here and go to Edit Curves, Attach, and Maya will attach them exactly the way I tell it to. So that's just something to keep in mind, that when you're using a lot of the NURBS tools, Maya is going to take guesses to try to figure out what it is you want. Now, I just got done talking about the fact that NURBS curves move in one direction. They move only in the U direction. There's also a V direction, but that only exists upon surfaces. And you can kind of see that if you open up Control Vertices here. Now, here's how this works. Notice we have another square CV. This is what is called the surface origin. This is the first CV in the U direction. It's also the first CV in the V direction. And you can see U right here. So the U direction runs with all of these isoparms. And the V direction runs in this direction, like so. So there's V right there. I highlighted it for you. And how does that work? That creates a surface by basically taking one curve, such as this curve, just as an example, and we make an infinite number of duplicates of it. In fact, watch this. If I take this curve and I Shift D it and make several duplicates of it, I mean, I'm just duplicating away like mad, hitting Shift D over and over and over and over. There we go. Now what we have is a series of curves that is simulating a NURBS surface. We have curves running in the U direction, and then those curves also, there's a series of curves, in this case just straight lines, that run in the V direction to provide us our surface. Now the cool thing about that is, because of a NURBS surface's parameterization, now that's a big word, and it is mentioned earlier in the Maya Fundamentals videos, so I just want you to be aware of the word. We're going to be using it a lot. You can access any point or any curve that exists upon a NURBS surface. For example, I can right mouse and I can choose isoparms. An isoparm is nothing more than a curve that exists on this surface. And I have, technically speaking, I have a theoretical infinite number of curves at any location along this surface. And you'll notice up at the top of the screen, Maya reports back the exact coordinates of that curve. That's at 0.46024, blah, 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 all of those numbers. That is exactly where on that surface the curve exists. I can also grab isoparms in this direction as well. Now that one didn't show up on my screen very well, but this one will. And it's because we have this cross-hatched network of curves that we're able to get a surface from a NURBS object. That's really all I wanted to kind of get across to you, that when you're looking at a NURBS surface, you're really looking at curves going off in 2 separate dimensions, which is going to be very important to remember that two-dimensionality, that bidimensionality of a NURBS surface as you go to perform a variety of operations. For example, if I want to cut this NURBS surface up, kind of like a tic-tac-toe board, kind of cut it this way and then this way twice as well, watch what happens. If I select a couple of isoparms here, and we'll grab an isoparm here and an isoparm here. If I try to cut this up, watch what happens really closely. Boom. We have 1, 2, 3, and then 1 and 2. Now, why did it do this? It's because Maya is going to keep track of the U and V, the 2 dimensions of this NURBS surface. So for starters, what Maya did was it cut in the U direction. That was the first direction that I was selecting isoparms in. So it cut here, then it cut here. Then it went to cut in this direction. But because this surface on this side had already been snipped off the original surface, those 2 isoparms that I selected horizontally in this case no longer went all the way across to the other end of this surface. This is now 3 separate surfaces. So it cut here, then cut here, and thought it was done. You got to keep in mind that Maya is always remembering that order of operations, U and then V, and it's keeping those separate from 3D space. So that's kind of just a starter to get you thinking about NURBS surfaces in maybe a slightly different way. Now, again, this is not something that necessarily needs to bog your brain down and give you headaches. It's very, very, very simple when you really get into it. But it is something you're going to have to keep track of when you're using NURBS surfaces. A NURBS surface is not going to, well, I can just show you, Let me just show you what I'm about to start talking about. Attaching a NURBS surface in U against a NURBS surface in V can pose certain problems. For example, like if I have a NURB surface here. And let's just duplicate it, and we'll put a NURB surface up here, and I'm going to rotate it 90 degrees. So it looks like the same surface. If I grab these two, and we go to Edit NURBS and Attach Surfaces, everything attaches just fine. But take a look at what happened. Maya had to swap directions on one of them. And how can we tell that? Well, take a look. We have swap 1 and swap 2. The U and V directions on the second object had to be reversed because Maya detected that these two edges were closest to one another. If I were to switch that off, this is what should have happened. The U direction on the first surface attached to the U direction on the second surface. So now we end up with kind of a twisted surface. So this is where, some of the tools and Maya's guesswork come in handy. If Maya hadn't guessed, we would have ended up with this. But Maya realized that these two edges were closest to one another, and so it swapped the U and V directions of the second surface to give us an attachment like so. Now, why is that important? Again, it all falls back to a curve cannot attach to the end of one curve cannot attach to the end of another curve. It's got to be beginning to end, beginning to end, beginning to end, over and over. Because remember, a surface is just a series of curves. They attach the same way. The end of a surface can only attach to the beginning of another surface. So what happened in our previous example, again, was Maya had to go in and internally reverse the directions. Now, how do you know which direction is what on a NURB surface? Sometimes it can be really hard to tell. I mean, like right now, if I just pull out a NURBS plane, how do you know where U starts, where U ends, where V starts, and where V ends? You don't, just by looking at it. It's very, very difficult to tell. But you can go to Display, NURBS Components, and you can show Surface Origins. And check this out. This will give you 3 lines. And in fact, let me go ahead and increase the number of patches on this surface just to make this a little more visible. And I'll go into wireframe view. You get a red line that is labeled with a U to show you which direction U is running. You get a green line with a V to show you which direction V is running. And then you get this blue line. This shows you the normal of the surface, so basically which way the surface is facing. Now this is most important for calculating lighting, for calculating collisions with dynamics, but we'll be talking about that as we kind of flow through. So it's just a way for you to be able to easily tell where a NURB surface begins and ends. If you are ever having problems attaching a NURB surface to another NURB surface, always check your surface origins first and make sure that you are trying to connect V to another V and a U to another U, and it's the end of one surface to the beginning of another surface. Make sure that everything lines up before you try your attachment. If you went through the Maya Fundamentals class, which hopefully you did, you might actually remember running into this yourself. Remember when we did the alien example way back when we did the little flying saucer, we had a little alien who was kind of like an eyeball on a stalk? Attaching the eyelid of that alien, in many cases, not every single case, depending on how you built it, to the body, which was made out of a revolve, caused you to have to reverse your surface direction before an attachment could take place. And I know that was the case when I had to build it, and many of the students who were having problems, it was because they weren't reversing that direction. So if you went through Maya Fundamentals, you might remember that particular example. If you don't, then just go with me. Take a look at my example here. And that's pretty much it. That really is the end of what I wanted to talk about, just that you have a series of curves across every single surface, and these curves run in the U direction and they run in the V direction. NURBS curves, in and of themselves, only run in the U direction. So that will wrap things up for this discussion. Thanks a lot.